Dealerships are casinos, billing $150 an hour for basic 15-minute driveway jobs. They weaponize fear, claiming touching one bolt causes catastrophic failure. They are lying. Today, I reveal 17 guarded tricks mechanics use on their own bikes. You will unlock surgical tire grip, prevent engine meltdowns, and decode your manual. Wait until number 1. I promise a controversial trick that changes how you listen to your engine forever. Number 17. The Owner's Manual, Severe Use, Secret. Every new rider opens the factory owner's manual, reads the maintenance schedule, sees the oil change interval listed at 7,000 miles, and celebrates the low cost of ownership. The dealership fails to explain the severe use clause buried in the microscopic fine print at the bottom of the page. Veteran mechanics understand the standard interval assumes a motorcycle cruising at a steady 60 miles per hour on a flat highway in mild weather. Do you ride in gridlocked city traffic? Do you live in a hot desert environment? Do you bounce the engine off the rev limiter during weekend canyon runs? That constitutes severe use. Heat degrades oil viscosity. Stop-and-go traffic shears the molecular structure of the lubricant. Mechanics ignore the standard column. They cut the factory mileage interval in half. If the book dictates 7,000 miles, the oil hits the drain pan at 3,500. Watch the dark, shimmering metallic sludge pour out of the engine block at 3,000 miles, and you will understand why professionals never trust the optimistic factory schedule. Fresh oil is cheap insurance against internal friction. You might change your oil on time, but if you trust the generic sticker on your swing arm for tire pressure, you ride on a compromised contact patch. We fix that in number 16. Number 16. The chalk test for surgical tire pressure. The aluminum sticker slapped on your motorcycle's swing arm telling you to run 42 pounds per square inch in the rear tire represents a massive compromise. Factory engineers calculate that specific number for a rider carrying a passenger and fully loaded touring luggage. If you ride solo, running that maximum pressure means your tire profile balloons in the center. You ride on a tiny, terrifying contact patch, sacrificing traction. Mechanics utilize the chalk test. They take a thick piece of white sidewalk chalk and draw a solid line straight across the tread of both tires from edge to edge. Then they ride the motorcycle in a straight line on flat asphalt for 100 feet. When you dismount and inspect the rubber, the truth reveals itself. If the white chalk wears off only in the absolute center, your tire is overinflated. If the chalk wears off on the outside edges but remains in the center, you are underinflated. You bleed or add air in 1 pound increments until that white chalk line wears off evenly across the curve of the rubber. This unlocks maximum glue-like grip, customized for your specific body weight. Traction keeps you upright, but a stiff binding clutch lever ruins a weekend ride. The fix costs 10 cents, and exactly how you do it is what's coming up next. Number 15. The zip tie cable, lubrication hack. If your clutch lever feels like pulling a cinder block through wet mud, your steel cables are starving for lubrication. Every time you grab a gear, your forearm burns. In heavy traffic, a dry cable causes hand cramps and missed shifts. The dealership service department will look at your machine, shake their heads, and quote you $80 to install a brand new factory cable. They claim the metal strands are stretched beyond repair. A veteran mechanic fixes the issue with pocket change and household trash. You disconnect the metal clutch cable from the handlebar lever. Pull the small metal barrel from its housing. You will notice crusty dirt packed into the pivot point. Take a clear plastic sandwich bag. Snip a tiny hole in the bottom corner. Slide the exposed metal cable through that opening. Wrap a thick zip tie around the plastic bag and the black rubber cable housing. Pull it tight with heavy pliers. You want to create a waterproof, sealed funnel that grips the rubber jacket. Take a can of aerosol cable lubricant. Stick the plastic straw into the top of the open bag. Spray the fluid into the plastic, filling it like a small balloon. Step backward. Gravity does the rest of the physical work. The fluid pushes deep inside the metal coils. Place a clean shop rag on the ground under the engine block. Walk to the bottom of the motorcycle where the cable meets the clutch cover. You will watch dark, contaminated sludge ooze from the bottom of the cable. This black paste is a toxic mixture of road grit, metallic dust, and dead grease. Keep the fluid in the top bag until it drips. Clear onto your rag. Reattach the cable. Pull the lever. It will feel like cutting warm butter with a hot knife. You kept $80 in your pocket. Hit the subscribe button if you love saving cash on repairs. A smooth clutch lever feels great, but boiling brake fluid is a literal death sentence on a steep mountain road. The tool to prevent disaster costs less than a cheap fast food lunch, arriving in the next section. Number 14. The brake fluid. Moisture pen reality. The dealership service writer points ominously at your master cylinder sight glass, notes the brake fluid looks a little dark, and quotes you $120 for a system flush. Mechanics do not judge brake fluid by its visual color. They know brake fluid is hygroscopic. It absorbs invisible water moisture from the humid air over time. Water boils at a low temperature. When you brake hard descending a steep mountain pass, the immense heat transfers from the brake pads into the calipers. That trapped water boils into steam. Steam compresses. Your brake lever pulls to the handlebar with zero stopping power. Mechanics use a $10 electronic brake fluid moisture pen. You uncap the master cylinder and dip the twin metal prongs into the fluid. The LED lights reveal the truth. A green light means zero water. A red light showing over 3% moisture means you flush the system today. Stop guessing with your eyes. Start testing with undeniable science. Boiling brakes cause crashes, but trapped air in your radiator causes catastrophic engine meltdowns. It's time to show the bizarre method mechanics use to burp their coolant. Number 13. The elevated front wheel. Coolant. Burp. Changing your liquid coolant seems simple. You pull the drain bolt, watch the old fluid spill into a pan, and pour fresh liquid into the top. But trapping a pressurized air bubble inside your water pump will warp your aluminum cylinder head in 5 minutes of riding. An air pocket prevents the coolant from circulating. It creates a localized hotspot. That hidden pocket of steam melts engine internals and turns your expensive machine into a paperweight. Dealerships hook your bike up to vacuum bleed machines. They charge you an hour of labor to do a job that requires gravity and patience. When mechanics refill a drained cooling system, they do not just pour bright green fluid into the radiator and slam the cap shut. They know the thermostat traps pockets of air in the lower hoses. To fix this, they park the motorcycle on a steep driveway incline. If they are in a flat garage, they jack the front wheel high into the air using a front stand or a block of wood. Air bubbles travel up. By elevating the front of the motorcycle, the radiator filler neck becomes the highest physical point in the entire cooling system. They start the engine with the metal cap off. They let it idle. As the engine block builds heat, you must squeeze the thick rubber radiator hoses with your bare hands. You will watch violent air bubbles burp and explode out of the radiator neck. When the engine reaches operating temperature, the thermostat springs open. A massive rush of trapped air will escape. Keep topping off the neck with fresh coolant. Once the green fluid flows, smooth like a glass river, the system is bled. You have zero air in the lines, and your engine will run ice cold on the hottest summer days. If you want to save thousands of dollars on maintenance bills, hit the subscribe button right now to join our garage. A cool engine runs great, but a misaligned rear wheel chews expensive sprockets into razor-sharp ninja stars. Throw away your useless factory manual and use the ancient method we are going to talk about right next. Number 12. The chain alignment. String method. Look at the stamped metal alignment marks etched into your rear swing arm. And the factory provides those tiny notches to tell you if your rear wheel sits straight when you adjust the drive chain tension. Mechanics know a guarded secret. Those factory marks lie. Due to mass production, manufacturing tolerances, and swing arm flex, relying on those stamped marks often means your rear wheel tracks sideways. A crooked wheel forces the steel chain to grind against the aluminum sprocket teeth, destroying your drivetrain in record time. Mechanics use the string method. They take a long piece of brightly colored masonry string and wrap it around the front edge of the front tire, pulling it taut straight back past the rear tire. By measuring the millimeter gap between the tight string and the leading edge of the rear rubber, they align the rear axle to dead center perfection. Your motorcycle will drop into corners with newfound stability, and your chain life will double. A straight wheel saves your chain, but a failing wheel bearing locks your tire at highway speeds. You should feel the danger before it happens. Number 11. The socket spin for wheel bearings. A failing wheel bearing locks your front tire solid at 70 miles per hour, throwing you over the handlebars. The terrifying reality is you cannot see a wheel bearing failing because thick rubber dust seals hide the internal steel balls. Mechanics do not wait for the wheel to develop a terrifying wobble. Every time they remove a motorcycle wheel for a routine tire change, they stick their bare index finger deep into the center metal bearing race. They do not just poke it. They apply downward physical pressure with their finger and spin the inner metal ring. It should feel like smooth glass gliding over wet ice. If they feel a single microscopic grain of sand, or if the metal ring briefly hesitates and clicks, they toss that bearing into the trash can. Do not trust your eyes. Trust the highly sensitive nerve endings in your fingertips to catch a failure early. Keeping the wheels turning is essential, but what about the burnt boot rubber melted to your expensive exhaust? Number 10. The WD-40 exhaust polishing trick. If you melt your boot heel on a hot pipe, you recognize the terrible smell. The thick rubber bakes onto your gleaming stainless steel exhaust headers. Add baked-on road tar, rock-hard dead bugs, and summer highway grime, and your beautiful pipes look like a disaster. The exhaust heat turns that debris into a concrete crust. Dealerships love this problem. They will try to sell you overpriced, tiny bottles of specialized chemical polishing compounds. Novice riders panic. They run to the kitchen sink and grab a harsh steel wool pad or a green abrasive scrubbing sponge. This action is a rookie mistake. Steel wool scratches the metal. It leaves a dull, ruined finish. You strip the factory finish off the stainless steel. The pipes will begin to rust. You just destroyed a $2,000 exhaust system in 5 minutes of scrubbing. Mechanics ignore the expensive polishing compounds. They reach for a blue and yellow can. They spray heavy amounts of WD-40 onto the cold exhaust pipes. Do not perform this trick on a hot engine. Let the penetrating oil soak into the baked-on carbon and rubber for a full 10 minutes. The solvents inside the lubricant break down the rigid bonds of the melted debris. Then go to your kitchen drawer. Tear off a sheet of standard aluminum kitchen foil. Crush the sheet into a tight ball. Dip the foil in water and scrub the dirty metal pipes. This functions due to basic material science. Aluminum is softer than stainless steel. The foil acts as a custom scraper. It shears away the melted black rubber and hard tar without leaving a single scratch on your exhaust system. The crushed foil conforms to the round curves of the header pipes. It reaches the tight spaces a mechanical polishing wheel misses. The chemical reaction combined with the soft metal works miracles. Wipe the pipe clean with a microfiber rag, restoring a flawless showroom shine. If you want to stop paying dealership prices, hit the like and subscribe buttons. A shiny exhaust pipe turns heads, but a dying electrical system leaves you stranded in the dark on a lonely highway. Now let's teach you how to catch the silent killer before your motorcycle battery dies. Number 9. The stator voltage pre-check. The worst sound in the motorcycling world is the rapid click, click, click of a dead starter relay when you hit the ignition button far from home. Dealerships will happily sell you an overpriced $200 battery and send you on your way. Mechanics know the battery is often just the innocent victim. The true silent killer is a burning electrical stator hidden inside the dark engine case, failing to generate power. Once a month, a mechanic grabs a $10 digital multimeter. They place the red and black metal probes onto the battery terminals while the engine revs at 5,000 revolutions per minute. If the digital screen reads below 13.5 volts, the electrical stator is bleeding to death. If it reads above 15 volts, the regulator rectifier is frying your battery with excessive acid boiling juice. Diagnosing the charging system. Early saves you from a terrifying breakdown. Are you learning new ways to protect your investment? Hit the like button and subscribe to the channel. We are building a massive community of self-reliant riders, and we want you in the garage with us. Let us get back to the list. Number 8. Grease the axle, not the threads. When mechanics reinstall a rear wheel, they grab a tub of waterproof marine grease. They smear a thick coating of the blue grease over the long, smooth metal shaft of the axle to prevent the metal from seizing inside the wheel hub over time. But they avoid getting a single drop of that grease on the metal threads at the end of the bolt. Applying grease to bolt threads alters the physical torque value. If your factory manual calls for 80 foot-pounds of torque and you grease the smooth threads, the lack of friction causes you to over-tighten that bolt to 110 foot-pounds. You will strip the internal threads, destroy the axle nut, and potentially crack the aluminum swing arm. Lubricate the smooth shaft to prevent rust. Leave the metal threads bone dry to ensure accurate torque readings. A secured wheel is vital, but pulling heavy brake calipers off the bike just to check pad wear wastes valuable riding time. Number 7. The penny trick for brake pads. You do not need to unbolt your brake calipers and remove them from the fork legs to inspect the remaining friction material on your brake pads. That wastes time and risks stripping the caliper mounting bolts. Mechanics carry a standard Lincoln copper penny in their pocket. They slide the thin metal edge of the penny into the narrow gap between the spinning steel brake rotor and the metal backing plate of the brake pad. If the actual remaining brake pad friction material is thicker than Lincoln's head stamped on the coin, you have plenty of safe mileage left. If the remaining pad fails to cover his tiny copper head, the pads are finished and require immediate replacement. It is a fast, undeniable visual field gauge used in professional racing pits to check wear in seconds. Stopping is crucial, but knowing the internal health of your sealed combustion chamber feels like magic. Number 6 turns your spark plug into a polygraph machine. Number 6. The spark plug porcelain lid. Modern fuel injection systems rely on complex computers and oxygen sensors, but trained mechanics know the engine's physical spark plugs are undeniable polygraph machines. They tell the raw truth about the combustion cycle. When a mechanic unthreads a used spark plug, they ignore the metal electrode at the bottom. They shine a bright LED flashlight deep down onto the white ceramic porcelain insulator hiding inside the metal shell. If that porcelain is bright, bleached white, the engine runs dangerously lean. A lean engine runs hot, threatening to melt a hole through the aluminum piston. If the porcelain is coated in thick, dark black soot, and the engine runs rich, washing the cylinder wall with raw, unburned fuel and diluting the engine oil. Mechanics look for a light biscuit, brown tan color. That specific color screams combustion perfection. Reading the plug tells you the exact health of the engine without hooking up a single diagnostic laptop. A healthy engine is beautiful, but a puddle of hydraulic fork oil on your garage floor ruins your entire week. Number 5 saves you a $400 rebuild with a piece of vintage trash. Number 5. The 35mm film fork seal sweep. If you walk into your garage and see a puddle of clear hydraulic oil dripping down the shiny chrome leg of your front suspension forks, the dealership will quote you $400 for a total fork seal rebuild. Mechanics know a brilliant free secret. 90% of the time, the delicate rubber fork seal is not permanently blown out. It is being wedged open by a single microscopic grain of hard dirt trapped under the soft rubber lip. Mechanics slide the thin plastic edge of a specialized tool or an old piece of 35mm photographic film straight up under the tight rubber dust seal. They rotate the thin plastic around the entire chrome tube. You will watch the offending sharp grain of trapped sand get scooped out. You wipe the tube clean, aggressively compress the front suspension 5 times, and the oil leak stops permanently. You just saved yourself hundreds of dollars in labor. Saving suspension money is fantastic, but ignoring the metal fragments inside your oil pan is a mechanical death sentence. Number 4. The magnetic drain plug autopsy. When you drain your dark engine oil into a plastic pan, you learn nothing about the internal health of your transmission gears or engine bearings. The dark fluid hides the truth. Mechanics rely on a magnetic oil drain plug. You replace the cheap factory steel plug with an aftermarket plug featuring a powerful neodymium magnet on the tip. When they unthread the plug from the hot engine, they treat it like a crime scene. A small amount of ultra-fine, powdery gray paste is normal clutch wear. However, if the magnet looks like a fuzzy metallic hedgehog covered in sharp, jagged steel splinters, an internal bearing or a transmission gear is violently tearing itself apart. The magnetic plug catches the failing steel components before they circulate through the oil pump and score the cylinder walls. It gives you the warning you need to tear the engine down before it throws a connecting rod through the engine case. Catching metal fragments is vital, but invisible vacuum leaks create erratic, terrifying idles that drive riders insane. Number 3. The soap and water vacuum leak test. If your motorcycle suffers from a hanging idle, where you chop the throttle closed, but the engine continues to scream at 4,000 RPM before slowly dropping, you likely have a vacuum leak. Air is entering the engine past the throttle bodies, causing a dangerous lean condition. Dealerships use expensive smoke machines to find the leak. Mechanics use a plastic spray bottle filled with dish soap and water. While the motorcycle engine idles, they spray the soapy water mixture directly onto the rubber intake boots connecting the carburetors or throttle bodies to the engine block. Older rubber cracks and hardens over time. And when the soapy water hits a microscopic crack, the engine vacuum sucks the water inside. The idle will instantly stumble and drop in RPM, and you will see the soap bubbles aggressively sucked into the fissure. You just located the exact source of your erratic idle for zero cost. A smooth idle is a joy, but a wallowing, bouncy suspension makes canyon corners terrifying. Number 2. The zip tie preload suspension tune. Factory suspension settings are engineered for an imaginary rider weighing exactly 160 pounds. If you weigh more or less than that, your motorcycle geometry is compromised. Your front end will dive violently under braking, or the bike will refuse to turn. Mechanics set their suspension sag using a standard neon zip tie. They wrap the zip tie snugly around the shiny chrome fork tube, pushing it flush against the rubber dust seal. They sit on the motorcycle wearing all their heavy riding gear, helmet, boots, and jacket. They balance the bike, lifting their feet off the ground for a second to let the suspension compress under their actual riding weight. Then they carefully step off. They measure the distance. The zip tie moved down the chrome tube. For a street bike, you want roughly 30 to 35 millimeters of suspension travel used just by sitting on it. If the zip tie moved 50 millimeters, the springs are too soft and you must tighten the preload adjusters. If it moved 10 millimeters, the springs are too stiff and you must loosen them. This 2-cent trick aligns your suspension geometry perfectly to your body. Perfect suspension connects you to the physical road, but our final trick connects you to the very heartbeat of your engine. Prepare to listen to your machine like a master mechanic. Number 1. The screwdriver stethoscope engine diagnostic. Modern engines are noisy. They click, they whir, and they clatter. When a new menacing ticking sound develops, novice riders panic, assuming the engine is destroying itself. Dealerships use expensive electronic acoustic scopes to locate the noise. A veteran mechanic grabs a massive long-shaft flathead screwdriver. They press the solid metal tip of the screwdriver firmly against the aluminum engine block. They press the hard plastic handle of the screwdriver directly against the tragus of their ear, plugging the ear canal. The solid metal shaft of the screwdriver acts as a flawless acoustic transmitter. It bypasses all the ambient wind noise and external exhaust sound, delivering the internal's mechanical frequencies directly to your eardrum. You touch the screwdriver to the top cylinder head. You will hear the rhythmic sewing machine tapping of healthy valve clearances. If the tapping sounds like a harsh, violent hammer strike, your valves are dangerously loose. You move the screwdriver down to the side case. You will hear the smooth whirring of the timing chain. If it sounds like a metal bicycle chain dragging across concrete, your cam chain tensioner is failing. This ancient acoustic trick allows you to isolate and pinpoint failing internal bearings, loose valves, and rattling chains without disassembling a single piece of the engine. You become intimately connected to the mechanical heartbeat of your motorcycle. You stop guessing and you start knowing. Click on the next video to continue the ride. Subscribe to our channel and don't forget to like this video.